We have a session. We have with us Piyush Chauhan, also from Eukarya. Um, he's based out of India, he's working from India, but I've also had the pleasure of working with him when I was at Eukarya. So over to you, Piyush.
Yeah, hello. Am I audible to everyone? Awesome. So, Kim-san just talked about how we have been working on conversion of data and how it's been pretty hard to convert data. Hello, yeah, and how Flow is trying to solve that and make it easy for people to convert their data. Uh, Now we're going to another direction where visualization itself has also been pretty for GIS engineer, and also given that the current state of CG, we have gotten so far with computer graphics these days. It's very hard to identify the difference between real and computer made in the CG world. But uh, GIS itself has not gotten that far. We can still differentiate what looks real and what's uh, made by a human or a machine. So with Navara, we are trying to bridge that gap and trying to make it more realistic for people to visualize their geospatial data, and at the same time also make something that is more flexible for people's need, and hopefully make more realistic visualizations of their own geospatial data while also keeping it more flexible for development. As we progress through this talk, we'll be talking a bit about how we're trying to tackle this problem. But a quick introduction about myself. My name is Piyush, and I've been part of Eukarya since last 4 years almost, and I am currently a staff engineer here, and I oversee majority of the products, and it also been trying to learn about GIS on the process. So in this particular talk, I'm going to talk about what Navara is. This is the map engine that we've been trying to build for some while, and why we're building it, how we're building it, and what's new and what is the plan ahead. And if you, by the end of the talk, have any questions, please feel free to ask. Okay, starting with what Navara. What's Navara? So it's a headless engine, which is flexible with visualizations and also uh, been developed in the focus of something of with the focus of uh, rendering large data sets with different types of LODs, and also have flexibility of uh, changing the rendering engines, or have the flexibility of do as much customization as possible. Does anybody here know what headless means? Okay, so headless basically means uh, keeping components separated, independent in a way that they don't affect each other. What that means is that your GIS processing should not be completely dependent on the visualization or the rendering of that GIS processing. So with Navara, we're trying to take this approach, which is common these days with game engines, where we are trying to make the map engine um, headless. That means if you the processing of GIS is completely separate from the rendering engine that you would use, which has the implication of that means is rather uh, the choice of rendering engine, that is your 3JS Babylon or mm, any other visually rendering library, is completely independent of how GIS data has been processed, and it'll be up to the engineer to decide what they want to use to render the data. But it's a long journey, and we're starting to tackle with the GIS part first, and then now, and later on, we like to part, do as much as possible for the rendering part. But as I'm progressing to this presentation, this is also the open URL which you can access to check all the examples of this map engine that we're trying to develop. Okay, moving on to what map engine is itself. So uh, for us, it's a software that can help you turn your GIS data into 2D or 3D scenes and make it mm, visually available to you, and it can show you what it actually represents. And it is majorly comprised of two main parts. There's the GIS engine, which mainly does the processing for you, and then there is a rendering engine, which mainly is responsible for drawing the scene for you. Now, and you can, in a layman term, can break down the whole pipeline of user input uh, and to uh, user input going to a GIS engine, and that GIS engine identifying what needs to be added to the rendering engine, and then finally that rendering engine shows you the image that you're about to that you want to see. So this is a neat example of how if you were to just add a 3D tile, you would be able to see it in the scene like this, where the 3D data itself has been shown to you in with the overlap of a terrain data and there is a tile data, right? So now maybe we understand what a map engine is. So now I'll explain why we are building Navara at the first place, and why can't we just why couldn't we just build a GIS engine, or rather a GIS processing library which could have just handle maybe some extensive extensions that are out there. So there are mainly three reasons. First one is the visual quality. As of now, as I explained at the beginning, the visual quality of the map engine these days is not great. CGI has gotten so far that you can see ultra realistic views of the data, but as of now, none of the map engines does that. You still can differentiate the difference between what's real and what's not. And then again, there's also a lack of flexibility where majority of the JS engine map engines locks you in. Once you start using them, it's really hard to work in between, or rather move one from one to another. So if you start using one for your own use cases, you would end up just keep on using it for the rest of the part of your use case. And finally, performance is also not been great. Maybe it's been great for small data sets, but if we are thinking highly realistic data set or data set with lots of detail, uh, performance has not been too great. So these are the three current problems that we're trying to address with Navara. To the answer to these all of these three questions is we're trying to address with each components. So the visual quality part is we're trying to be the early adopters of Rust and WebAssembly, and also trying to rethink how map engines has been great so far. We're trying to get a lot of inspiration from game engines and how they have been designed and how they do visual quality and visual data processing. And keeping flexibility in mind, we are also trying to build a lower level API that we're trying to build a flexible developer based library that can be easily used by developers but also does not lock you into a single map engine itself. And for performance, we are trying to use Rust and WebAssembly to do rendering in the on the fly on your browser so that it can be much more faster. And I will, as I progress through this presentation, I'll share with you what it actually means and how it looks like. Okay, moving on. So far we've been able to understand what Navara is and why we're building Navara. Now I'll explain how we're building it. So it looks very complicated, and don't get scared about it. So I'll explain it to the next slide, but this is the complete architecture of the whole map engine, which is comprised of a GIS engine, which basically handles processing of the GIS data. And then there is a rendering engine, which just handles uh, visualizations and communication aspects to the browser itself. So each browser is made up of browser engines, and those also needs communications. So the rendering engine basically is a lower level area which interacts with the browser engine, and the GIS engine is mostly the main crux which is handling all the GIS data. So this diagram basically on the right just tries to make it a little bit easy to understand. Just there's four components involved, actually three components involved: the interaction of the user, in this case a GIS engineer or a software developer who's trying to interact with the rendering API. something that you see in the form of cesium API or cesium's library or uh, maplib-based library. So all of these are rather user-facing libraries that you use for your use case. You don't really go ahead and start making changes to the rendering engine itself, right? So that's what we mean by the rendering engine. Rendering engine is just an API that you use to add your geospatial data, and it's should be as flexible and easy as possible for anybody to use, right? So if you see on the left, this is how you would just add a normal layer. You have a cesium 3 tile data set and you just want to add it. So you just easily explain it in the form of a JSON or an object where what type of data set you're using, what's the URL of the data set, and what's the what would you want, how you'd want to see it. So if it should have some sort of color, or if there should be some metalness or roughness, things that just would make it more visually appealing. So this is the first layer, that's where the user interacts mm, with the map engine. The second aspect of the execution is the once the GIS engine, or rather the map engine itself, receives what you want to do. There is the GIS engine, which basically tries to fetch the data set that you're trying to add, and also tries to update the location of the camera at which you would be maybe looking at that data set. This is the whole workflow of how things move whenever you're trying to add any data set to your map or map library or any of the map engines that you use out there. So the GIS engine's job is to fetch the data. It is also to locate where this data set is available, so that whenever you this added the data set will get added, you'll be looking at that viewport. And then finally, the last part is the rendering part, where the GIS engine interacts with the rendering engine, which basically uh, renders the mesh that is basically available to that data set, and then shows it to you that particular location. And if there is some sort of styles that has been attached, it also attaches that style to that data set. Now, that was like explaining it in very layman matter, but if you are interested in the details of exactly how it's been done, we already have a blog post named reearth.engineering which explains them in proper detail. uh, there is a QR code that will come later on, so you can just check that out. So that kind of covers up everything that is about Navara per se. Now I'll explain what we've been building recently, and since it's an ongoing effort. Just uh, every year we almost try to add as much features as possible, and then there is also a roadmap or a timeline that we're chasing. So starting with photorealistic rendering, we have been trying to visualize real data and also try to make high realistic view of the data sets, geospatial data sets. This is nothing but 3 tile data and some flat data, which is in the form of mm, polygon, and then there's some cloud and rain and fog that has also been generated using some of the NASA's satellite data, and the rain is just been simulated in normal manner. It's not accurate in a way. So uh, this is how in reality it would look like, where if you want to just simulate the time of the day. So if there were to be night, how it would look like, and if there were to be uh, day of the time, so the visually it will look rather bright. So there are a few options that we have been trying to explore so far. So if you were to uh, color code the buildings that you are seeing right now according to the height, you can just do that. There is ways to color code the buildings on different manner. This is nothing but just conditional styling that is very common in any of the map engines that you've been using. But visually, we've been trying to make it as much realistic as possible. Now, this data set is obviously LOD1, so it's not that realistic, but if you were to see it in the form of LOD3, it looks much more realistic. But and ever since Google photorealistic tiles has been there, it's getting much and much better. Moving on, uh, there's also things that we thought that was not possible. It's something that we've been trying to work on. For example, uh, creating elevated heat maps. So heat map itself is it's been pretty complicated to generate in any of the map engines out there. But if you were to make elevated heat maps, that's another story. So we've also been trying to use the DEM tiles to provide elevated heat maps. So basically, this is nothing but terrain data overlapped with some heat maps that has been generated on the basis of, mm I think this is cloud distribution as of now. Or actually, this is height-based heat map. So each the higher the height is, the more colored or darker it will look like. This is also one of the things that we've been working on. It's called arc lines. Now, this these arc lines that you see in this picture is not random. It's actually showing the communication routes that has happened and has happened as an export has been happening in the Japanese region. And basically, these arc line is just used to visually explain how a data might be flowing. And this is something that is been if you know, if you used GitHub or Stripe, it's something that has been there for a while in their websites. You could just see how their transactions moves, and I think it's pretty neat. And we just try to build something like this so that we could see if it's possible to have arc lines. This is actually MBT polygon. Looks pretty realistic, right? So this is one of the other things that we've been working on. This is nothing but just 3D tile, sorry, MBT data in the form of flood data in the form of a river. And there's also some material setting that has been used to reflect off the sunlight that is coming off the sun. This is another one thing that we've been using. It's like MBT polylines, nothing new there. Just blue is represented by representing the rivers in Japan, and the whites are just the border. This is the point cloud data that we've been trying to visualize for a particular region. And this is a model animation that just uh, has controls like how you would have in a game. Like W means you move forward, A means you go to the left, D means you go to the right. So yeah, the guy just literally went to Mount Fuji. Okay, now I'll explain why how all of those examples was made possible. Actually, I think we're running short on time, so I'll just quickly go through them. First of all, this obviously we've been working on a JavaScript based library because that's been used widely. You can basically add layers like this, just like how any map engine generally handles layer. If you were to do customization on your data set, just basically the structure here is just common. Like you indicate the type, you indicate the uh, location or the source from which you want to get the data, and also if there were to be any customizations, you just add that. So we're trying to make it as simple as possible for people to use. This is nothing but the change in the tile set that has been used. This is adding an effect of aerial perspective. So if you were to look at the earth, it will not look completely bright, it will look half bright because half of the world will be asleep. So same thing but different color. Now this is the part which I feel like is the most interesting and took a lot of time for us to develop. What you see here is the elevated map of three tiles, but to make it highly realistic, we had to work on fog, atmosphere, and also the sunlight effect. And putting all of that together made this high realistic view. Uh, yeah, this is another thing. You can add cloud effect. These clouds are randomized. They're actually showing any real effect. If you were to, if you have your own custom data, you can just add it like this. This is something that I touched upon at the beginning. If you were to customize your three tiles on the basis of a parameter or a property that is available on that feature, you can do so by writing a small expressions. I think that brings us to the end of this presentation. So in 2025, we were working on improving the visual API, And in 2026, which is this year, we plan to release a beta and also open source this map engine. And in 27 and around 28, we also plan to enhance this API and also do a RC release. And if you this talk made you curious, you can just check out this a blog post, a blog website that we maintain. This is where we post a majority of the engineering work that we do. And there's also the Discord through which you can reach out to us. Thank you so much.
Thank you, Piyush. Some really, really ambitious work, both with Flow and Navara. So now we'll take some questions. Anybody got any questions? Yes.
Uh, Very nice presentation. I just want to know, you have published this Navara as a open source software, or still a handy mode?
Yes, so as I mentioned, we plan to make it open source this year. It's not been done just yet, but we plan to, within this year, we plan to open source it and also release a beta version that can be used by anybody.
Means you are working customer?
Of course. Uh, Although we are based out of Japan, we are completely global. So we do have members in India as well. And if you are interested in a POC, just reach out to us on Discord or maybe find us on the booth.
Okay.
Yeah.
Yeah, just to answer that, I was also working in that company and they have members all over the world. They're based out of Japan, but they're very open and inclusive. And you can just reach out to them. They'll be happy to respond. Anybody, any questions? Yeah.
Amount of data you have used for the run.
Amount of data, what do you mean by that?
It is GB, TB.
Oh, yes. So what I just explained here is just visualization tool. So we did try to keep the efficiency in mind.
Input data, input data.
Input data. So you're saying what should be the size of the input data that can be visualized at once?
Now you are showing a rendering. So what? Yeah.
Oh, yes. So that will be the size of a 3 tile. I think it's around 20 MBs. This is just a very small region. Sorry, I cannot hear you.
Did you tested your beta version with reference to the increasing the data? Terabytes of data.
So, I mean, did you test this thing with more like up to terabyte of data when you're
Oh, yeah.
building the-
So it's not humanly possible to render terabyte of data on the browser.
You are using GPU rendering.
Yes,
See, you are using GPU rendering. It really does things for terabytes data when you use GPU.
You're saying it's
But I think question is how much data can you
render at once, right?
Right, yeah.
Yeah. So browsers, basically, this is WebGIS library, right? So it's supposed to be rendering things on browser, and browser itself has limit of their own. So you can go up till GBs, but I don't think you can go to terabytes. I don't think that's humanly possible as well.
Browser constraints.
Yes, yes. So it's a browser-based library, so you would want to render it. We do have plans to make a desktop version, but if you and I think all the map engines is designed in a way that they don't really uh, they're not created in a way that they would handle so much data at once. It's rather, if you want to visualize a particular area, you would just render that, and if you want to visualize some other data, you would just render that.
So a more appropriate thing to say would be that you can have like TBs of data on the back end, but whatever you're looking at right now, it will only stream that part.
Yes,
Yeah.
yes, exactly.
Does that answer? Yeah. Anybody, any other questions?
Uh, is it possible to add a 3D texture which we created from any buildings or anything? Is it
Of
possible?
course, yes. It's one of the things that is possible. And if you want to even say change material and also add must like makes changes that might have not been done so far, the one flow that Kim San just talked about, it's also that's where we can do also the modification of the material. But if you just have material already attached to your GLB files, you can just directly render it on Navara.
I think the context here is that currently, if you're talking about 3D GIS data, the only viable option 3D is these. So Navara plans to bridge that gap with like visualization of data. So yeah. Anybody? We have time for one last question.
So what level of LOD we are considering for this rendering? If we have a LOD level of 3 or 2, so is it possible
Yes.
for that in a
So
micro level or like from the house to the community? So is it possible?
as of now, I think we are trying to reach to LOD4 level. We've already tested it with LOD4. So anything from LOD0 to LOD4 is possible, yes.
Okay, that's all the question for Piyush, and thank you for coming here and talking about this. So a round of applause for Piyush and Yukarya.
Thank you, thank you.
We'll start the next session in 5 minutes.